I've heard people say CO2 levels are rising, but what does that really mean? Let's load and parse the Keeling Curve data. This will involve parsing the dates, parsing the numbers, and replacing a Sentinel value that represents missing data with not a number. Let's take a look at the Keeling Curve. The Keeling Curve is a daily record of global atmospheric carbon dioxide concentration. This is a pretty wild interactive data viz right here where it goes back 70 million years. Whoa, that's next level. And then 800,000 years, and then 10,000, and 2,000, and 1,700 to present. And it looks like the data collection or estimation method is different before this point and after this point. So let's look at full record. This is carbon dioxide concentration at Mauna Loa Observatory, and it shows this consistent increase with a yearly periodic pattern. Let's reproduce this visualization with D3. The first step is to get the data. Let's see, permissions and data sources. Here it is, CO2 data starting in 1958. Okay, cool. There's a little map that shows where that is. It's in the middle of the ocean in Hawaii. And then there's a link to a CSV file. And there it is, 83 kilobytes. So let's load up this data. I'll start by forking this penguins dataset, and I'll call it Keeling Curve data. And then I'll clear out the README, and I'll clear out data.csv. And then I'll just drag and drop this CSV right in here. And there it is. Okay, well, it turns out it's not really a CSV file. It's got all this sketchy stuff. This is more like a description. And then it's got something that sort of resembles CSV. All right, this is a pretty good example of real-world data where you get a data file, but it's not clean. You have to clean it up before you even can parse it. But that's all right. Let's just work through it. First of all, what to do with all this content here. I don't want to just get rid of it completely, but I'm going to cut it and then paste it into the README and say something like, the following text came with the CSV file, and then use triple backticks to quote it, and then it shows up in the description like that. Okay, great. Now, data.csv is not really CSV quite yet. We got to get rid of this white space. And then we got YR, MN, and you know, with CSV, I think the white space will become part of the column name, so I'm going to get rid of that white space just manually here. We got date, another date, and then it seems like these other rows are kind of extensions of the column names. So I'll just put date space Excel, and that makes sense. We got year, month, date, and then date Excel. Maybe that's some kind of Excel specific representation. I don't know. And then we have this CO2 comma seasonally adjusted. And I think that's supposed to be one column, but if it has a comma in it, we have to quote it. Otherwise, it'll be considered a separate column. So I'll just put CO2 comma seasonally adjusted. Or maybe, hold on. Maybe CO2 is the column, and then seasonally adjusted is the next one. Okay, I think that's more likely. Because we've got fit, which is this other thing, and then seasonally adjusted fit, which is the next thing over. And then we have, what, CO2 filled, and then seasonally adjusted filled, and then STA, which I suppose is short for station. And the unit is ppm for all of these. that can come through in the way that we label it. So I'll just delete these 2 lines, and now we should have valid CSV. And when this runs, it does seem to parse the new data. Okay, fantastic. Now we just got to clean this up a little bit. See, there's a bunch of white space that we don't need, and figure out what column to plot, and then we can make a line chart of this. All right, so over in index.js, we have all this penguin stuff. We can get rid of that. And let me change the font size so we can see the full data for the first row. And I'm noticing we have a white space issue with the STA. So let me just fix that. I'll delete that space before STA. And now that goes away. Okay, great. All right, so looking through these values, we have year and month. And in the data, we have 1 row per month. I don't think we'll use these 2 columns because they don't really make that much sense to me. And then all of these columns appear to be numbers, but then it looks like they're using a Sentinel value to represent missing data. I don't think minus 99.99 is the actual reading. My guess is that that represents missing data. So here's what I'm thinking for the approach to parse this. We want the date as a JavaScript date object. So let's make a new field called maybe lowercase d date that will be a JavaScript object, a date object, using year and month. And then we can treat all of the quantitative attributes or numeric columns the same, with some logic that will trim the white space, parse the value, check if it is the Sentinel value, minus 99.99, and if so, I think the best move might be to replace it with not a number or null, because if we leave the minus 99.99, then that'll come through as that number in the visualization, which we don't want. All right, that's the plan. Step 1, parse the date. I'm just going to copy that as a reference. Let's define d.date to be a new date object based on the year and the month. So let me isolate the year to be d.yr, and then the month, which will be d.mn. But notice that this one has some extra white space. So to get rid of that extra white space, we can say .trim. That's a method available on JavaScript strings. And to show you what I mean, we can put that text in the console here and just say .trim and see how it removes the leading space. It also removes any trailing spaces. And then let me research a little bit about the JavaScript date constructor. Okay, here's the MDN documentation for it. And it says here we can pass in year and month index to the date constructor. Now, I don't know if those are supposed to be strings or numbers. Okay, here it says these are integer values. Okay, since we need to parse those into numbers, let's use unary plus on both of them. And we might as well use the same variable name here, and notice that it's the month index, beginning with 0 for January and going to 11 for December. But this data we have here starts at 1 and goes to 12, so we're going to need to subtract 1. So I'll say month index is month minus 1. Now we can use the date constructor and pass in year and month index. And now the date shows up right here. That looks correct. All right, that's how we can parse the date. Now let's move on to parsing all of the quantitative attributes. We did something quite similar to this before with the UN population estimates, where we logged out all the columns and then made a variable called quantitative attributes and just commented out the ones that were not quantitative. Well, let's use the same approach for the Keeling curve data. Here are all the columns, and I'll say const quantitative attributes equals this array. Year, month, date, date Excel are not quantitative, and neither is STA, the station ID. But all these other ones are. So let's process these all in the same way. It's quite similar to what we did for the UN data. So I'll just drop that code in here. And surprisingly, it seems to work. Let me just check something real fast. If I have a string like this, and I use plus, it does parse. But then if I have white space in that string, oh wow, it does parse. That's cool. I didn't know that. I thought we would have to trim it and then parse it, but hey, if it works, it works. Now we need to handle this special case. This value, minus 99.99, is what I like to call a Sentinel value. It's a value that has a very special meaning. It's not supposed to be interpreted as a number. I think this means that there's missing data. And typically, not a number is used if there's missing data. That's a pretty decent way to handle it. So let's replace this Sentinel value with not a number, NaN. To do that, we can first stash this value as a variable. I'll call it value. And we can use the ternary operator to check, is that value equal to minus 99.99? Question mark. If it is, then let's replace it with not a number. Otherwise, we use the value itself. This is called the ternary operator. The first thing here evaluates to a Boolean, true or false. And if it's true, then this thing gets evaluated. If it's false, the second thing gets evaluated. So this should be replacing all the occurrences of the Sentinel value. And you know what? Let me make this a variable called Sentinel value, just so it's super clear. And then I'll even add a comment that says, this value represents missing data. And based on the template, the data is being exported. Okay, last but not least, let me set the custom URL to be Keeling Curve data, and that should do it. All right, that's how we can load and parse the Keeling Curve data. Now I'm looking forward to actually create that line chart from this data.